Hey, so we're gonna do the earthquakes gizmos. So first part, I said you should check the key in the bottom left corner to make sure your recording station is 860 kilometers away. So when I click on this, I look at it right here. It's 860 kilometers away. So we're in the right spot. Then it says press play, click pause as soon as the purple P wave hits the recording station. About how long did it take for the P wave to hit the recording station? The time is in the upper right-hand corner. So it's about approximate. So we're going to hit play. Here, let's reset this. Let's hit play. And as soon as the purple wave hits, about right there. So it's about right there. Time is about 150 seconds. Right there is where my time is. Okay? So let's go back to our answers. And which one of those is about that? About 156. About, approximately. Okay. There you go. So pick that answer. So press play briefly to let the P wave pass, but pause again before the S green wave passes. How would you describe the recording on the seismogram from the P wave? Okay. So we basically, let's do before the S wave gets. So what do I look? There's my squiggly lines right there. Okay. So what I described it as a flat line, a small squiggle, or a large squiggle. There it is. I don't know. Take a look at what you think. All right, press play. Once the green S wave hits the recording station, press pause. How long did it take for the S wave to reach the recording station? Okay, so we're going to hit play. And right about there. Okay, there's our time right there. Okay, it's now hit the station because this is our recording station right here, right? So let's see what we got. Ooh, we're right on. There you go. All right. Next, it says allow the green S wave to pass, then press pause again. How would you describe the newest recording from the seismogram, from the S waves? So we're going to hit this, let it go by. Ooh. All right. So how would you compare this? Compared to that, okay, you can kind of compare it, kind of see the answer there. All right, so there you go. Easy enough. Next, reset your gizmos. Press play and let the gizmo run for the full 550 seconds. If you were in the recording station when an earthquake hit, what do you expect the P wave lines to feel like? All right. So it says reset, press play, and let gizmo run for the full 550 seconds. Okay. Reset. Play. Okay, there's that. Okay, there's that. Okay. So we did that. There we saw. So the question is, what if you were a recording station when the earthquake hit, would you expect the field waves to feel like, what do you think? Look at the vibrations when the P wave hit. Not very big. Okay. All right. If you're a recording station when the earthquake hit, what would you expect the S waves to feel like? Well, look at the difference. Here's the S wave right here. Look at the difference. A lot more. And you can see the thing barely shakes here, but then it shakes a lot there. All right. Cool. Distance to the epicenter. Delta T, the change in time, is the distance in time. All right. Difference in time to the epicenter. So it says reset your gizmos. Click and drag your recording station to a new place so that it's only 300 kilometers from the epicenter. Click play and let it run 550. Which waves are the fastest? We should already know this answer, but we can do this anyway. All right. So I'm going to move this. And right here, again, this tells me my distance. All right. Reset. Grab it. I'm going to make it 300. Right. And very, 295. 300. Right there. Oh, I'm so good. All right, let me hit play. All right. Pretty much. So, yeah, which waves are faster? We should already know that, right? Which ones show up first? Right? pretty much easy. We know that one. All right. Says turn on the show time probe. Move the green probe to the start of the P waves and move the blue probe to the start of the S waves. See the example below. What is the difference in time between the P and S waves? Okay. So, show time probe. So we go right here. We go. This one, that's the start of the P wave. Okay. Right? And then this one is the start of the S wave right here. All right. So what's our time difference? All right. 41 seconds. All right. It's approximately, that's what this means. Ooh, there you go. There's our answer. Pretty easy. Whoa, the lights just went out. All right. There we go. Let's quiz yourself. So it says, in which seismogram is the time probe placed at the beginning of the P wave? Okay, remember the P wave is starting the first little blibble. No. First little blibble? No. First little blibble? Maybe. And then first little blibble? No. So right where first, this is the P wave. Okay. So there we go. We know that one. Suppose that an earthquake has just occurred as pictured below. The first P wave is shown as the larger circle, the purple one. And the first F wave is shown as the smaller one, the green one. What would the seismogram in the recording station A display at the moment the image was taken? Okay, let's think about this. It's here. Have any waves arrived yet? All right. So, squiggly lines, squiggly lines, squiggly lines. Think about it. The waves haven't arrived yet. Nothing has happened yet. Should be pretty easy. All right. 3, which of the following has 2 vertical probes in the proper positions to find the correct value of delta T between the P and S waves and the start of S? Remember, all right? Okay. No. 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 Ding, 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 ding. P wave, S wave. There we go. All right. 4, an earthquake has just occurred. Seismic waves from the earthquake are detected at 2 recording stations. At recording station A, the delta time is 45 seconds. At the recording station B, it's 100 seconds. Which recording station is farther away? Okay, so remember, the farther, the more the distance between the P and S arrival time, all right, the farther away you are. So since this is 45 seconds, so it's P wave, and then it took 45 seconds for the S wave to show up, and the next one was P wave, and then it took 100 seconds for it to show up. We saw this in class, that which one recording station is farther away, it's B. All right? And then number 5, suppose that the recording station N is located 200 kilometers north of the epicenter of an earthquake, and recording station S is located 100 kilometers south of the epicenter of the same earthquake. Which of the following statements would be true? At recording station S, the S wave would arrive before the P wave. Is the S wave ever going to arrive before the P wave? No. The P wave would arrive at recording station N before it arrived at location S. Well, N is 200 kilometers away. S is only 100, and they travel out at equal speed in all directions. So no, that's not true. The value of the change in time, SP recording station N, would be greater than at recording station S. So think about it. It's farther away. P wave is going to be farther. So would that time be difference? Yeah, it would be. Okay, so N is located 200 kilometers, so since the value would be greater because it's farther away. All right, make sense? There you go. So hopefully that helps you get all those answers, man. All right, let me know if you have any questions. Good luck.